So hello everyone. So today we are going to learn about the setback distance. So what is setback distance? Setback distance is the distance required from the central line of the horizontal curve to the obstruction at the inner side of the curve to provide adequate side distance. So setback distance depends upon the required side distance, the radius of the curve and length of the curve. So what is setback distance? Okay. So I'll be showing you what is the setback distance. So this is the horizontal curve. This will be the center line of the curve, and this is the obstruction, that is it might be house or something like that. So the distance, this distance is known as the setback distance. So how much setback distance will be kept so that the vehicle moving in here can see the vehicle here, so that the vision will not be obstructed by the this building, that is known as the setback distance. Okay. So the setback distance have the two cases. The first one is when length of curve, the length of curve is greater than the side distance. Length of the circular curve is greater than side distance. The first case is like that. So LC be greater than the side distance. The angle subtended by the arc length S at the center be alpha. So the angle subtended by the arc length, that is a side distance. Angle subtended by the side distance at the center of is alpha. Okay. So I'm only assuming to be a single lane road. I'm not assuming it to be a double lane road. So this is the distance, and the value of is known as the side distance. Okay, and this is the center line of the road, and this m dash will be the, oh, no, m dash will be the side distance. If this is the center line of the road, then m dash will be the side distance. So let's calculate. So what is alpha? Alpha equals to s by r, because this is r. This is the radius of the curve. Therefore, the half center angle, that means only this portion is given by s by 2r radians. Okay. Now, converting it into the degree, we know that. So distance from the obstruction to the center is r cos alpha by 2. So distance from the obstruction to the center, that means, let me explain it right here. So this is the what do we say? This is the s, right? And this will be m, as given in the question. This will be m, and this is r, and this is alpha by 2. So what will be this value? This is so cos theta equals to b by h. So what is b by h? Opposite, this is hypotenuse, this will be perpendicular, so this is b. So b means that this distance, and h means r. So r cos alpha by 2 will be the value of b. What is b? B means the distance of to here. That means the distance from the obstruction to the center of the curve. So the distance from the obstruction to the center equals to r cos alpha by 2. Therefore, setback distance, we are given a setback distance equals to m, right? So m equals to what? Obviously, this is r. Then the distance up to here will be what? R. So what is m? M equals to r minus r. This is obstruction. Okay, this is obstruction. And from here to the center is equals to r cos alpha by 2, and from here to the center of the lane equals to m. The lane center should be there. Okay, so this is, I'm assuming it had to be 2-lane road, then this should be the central lane of the road. Or for more accuracy, the inner lane, center lane can also be taken as from the center line of the inner lane, the distance m can also be taken. Okay, for more safety, because the obviously in outer curve the visibility will be good, but in this inner curve the side distance is more affected. That's why we can take this as a critical case, and we can find the value of m. Okay. So the value of m will be r minus r cos. For multi-lane road, if d is the distance between the center line of the road and the center line of the inside lane in meter, the side distance is measured along the middle of the inner. I just explained it earlier as well. So I assume it had to be a critical case. Okay, and let me explain a bit clear. So this is my road, this is my obstruction. This is the, let me draw the center line in black. So this is the central line of the road. Okay. And this is the center line of the inner road. This is the center line of the inner road. And this is the distance m for critical case. And I assume the distance this to be d. Okay. I assume that distance to be d. So this distance is d, then what will be the value of m? M will be similar r, same as before, and here will be r minus d cos alpha by 2, because the center line will move along like this. And what will be this value? The value of this will be r minus d, because the whole radius will be r minus d. The value of this will be r minus d. That's why r minus d cos alpha by 2. Okay, like this. And another. Okay, fine. So alpha, what will be the value of alpha? Okay, similar. Alpha, what will be the value of alpha? Alpha will be s divided by r minus d. Alpha equals to subtended angle divided by length. So alpha will be s divided by r minus d. So let's look at the second case, that is the LC value is less than s. Okay. So in this case, let me explain it a bit clearly. So well, let's not make it by, let's make it by blue pen. So like this, the value of LC will lie between this. This is the value of LC, and the stopping side distance is from here to here, that is s. The value of LC is up to here, and stopping side distance is up to here. So what will be this value? This value will be LC minus 2, s minus LC by 2, and this value will be s minus this value will be s minus LC by 2 up to this portion. Okay. So now the angle subtended will be by this horizontal curve, and this length is alpha. Okay. And here is the obstruction. Assume the obstruction will be, where will be the obstruction? Because the vehicle will be moving here, and it should see the object at here. That's why the obstruction should be here. So that this is the critical case, we need to calculate the setback, you know. So for that, the obstruction should be here. That means the side distance should be obstructed by this obstruction. So the obstruction is here, and there will be a some case here, and the total value is from here to here. That is, let us consider this as m1, and let us consider this as m2. So total obstruction m equals to m1 plus m2. So let us find the value of m1. What will be the value of m1? So we know that if this is alpha by 2, okay, this is alpha by 2. So what will be this value? This value will be r minus r cos alpha by 2. We can clearly see that. Look here. What will be this value? This value will be r cos alpha by 2. And what will be this value up to here? It will be r. That's why r minus r cos alpha. I think it is pretty much clear. So let's move towards the second case, that is the value of m2. Let's move towards the value of m2. Okay. So let me explain the value of m2 by the green. So the value of m2 means up to here, right? So how the value of m2 should be explained? The value of m2 is here. So looking at this curve, so this is s minus LC whole by 2, and this is m2. And what will be this angle? Look here. This is alpha by 2. This is 90 minus alpha by 2. So what will be this angle? This will be 90 minus alpha by 2, right? So what will be this angle? Oh, no, no. What will be this angle? Look here. This is 90 minus alpha by 2. The line is parallel to each other. So this angle will be 90 minus alpha by 2, right? And obviously the line cutting the core portion will always be in 90 degree. So this is 90 degree, this is 90 minus alpha by 2, so this angle will be alpha by 2. That's why this angle is alpha by 2. So we need to calculate m2. So this is p and this is h. So what is the relation? That is relation is sine alpha by 2 equals to p by h. That is m2 equals to s minus lc by 2 into sine alpha by 2. So what will be the value of m? So the value of m will be r minus r cos alpha by 2 plus s minus lc by 2 sine alpha by 2. The question will process like that. Okay, so we have given it in this way. And in multi-lane road, the r will be subtracted by d, and alpha will also be subtracted by alpha will be lc by r minus d. In previous case, the alpha was, what was alpha? Alpha was s my r minus t. But in this case, it is lc because the angle subtended is only lc length. That's why. Okay. So let's do the question regarding this setback. And so a four lane divided highway has a curve of 80 and has a radius of like that. Okay. So what is the curve? Curve 1000 meter long and radius equals to 550 meter is the radius. And what is the length of the curve? Length of the curve is 1000 meter. Safe stopping side distance SSD equals to 250 meter. So here SSD is less than LC. That's why LC will be more and SSD will be less. This will be LC, this will be LC, and this will be SSD up to here, right? So this is the first case question. So we'll solve the first case question. We need to remember the formula for the setback. Okay. So let's solve the for this main problem will be what will be the value of d. What will be the value of d? It is given as the question four lane divided highway. So four lane highway means this would be one lane, two lane, three lane, four lane. So what will be the middle lane? Middle lane is this, right? So middle lane up to the center of this lane. So in four lane highway, the width of the each lane will be 3.5 meter. That's why this, what will be this distance? It will be 3.5 into 2. That is 7 meter. Okay. So what will be this distance? This will be 3.5 by 2 because this distance is 3.5. So this distance will be 3. Because the center line of the inner lane. That's why this is 3.5 by 2. So the value of d should be, d will be 7 minus 3.5 by 2. The problem was only to find the value of d. Otherwise, the solution will be very simple. Okay. So the value would come as 5.25 meter, and side distance is given as 250. R is given as 550. So alpha equals to s divided by r minus d into, this is in radian. That's why 180 by pi. So on solving it, we will get the value as 26 degrees 17 minute 40.31. S will be 250, R will be 550, and D will be 5.25. So on solving, we'll get the value of alpha as 26 degrees 17 minute 40.31 second. Okay. So what is setback distance? We remember the formula r minus d cos alpha by 2. So the setback distance will be, so will be given by this formula. But what we are asked in the question, calculate the minimum setback distance from the inner edge of the curve. So what is mean by the inner edge of the curve? Means from this inner edge. Inner edge means from here. Look here. From this inner edge. We calculate the setback from M from the middle edge, right? From here. This is M. Okay. But we need to calculate the setback from this middle edge. So what we'll be doing? So we'll be subtracting this distance. That is 3.5 into 2. Okay. So at last we'll be dividing 3.5 into 2. So on solving this, what will be the value? It will come about 12.53 meter. Like this we can do it. Okay. Now the second question is, the setback is always from the center of the curve. Okay, the setback will be always explained from the center of the curve, even though we assume that the d will be the distance between here, but the setback is always from the center line of the curve. All right, setback will always from the center line of the curve. So the next question is, what is the radius of the center line of the circular curve? 650 meter, and the distance, the length of the curve is, and the side distance required is 400 meter is the side distance, radius is 350 meter, length of the curve is 300 meter. So this is the second equation, second question, second case. Okay, so in second case, what is the formula of the d? What will be the d? Two lane, two lane. That's why what will be the value of d? D will be 3.5 by 2, right? What will be the value of d? What will be the value of d? The value of d will be 2 lane. That means 3.5 minus 3.5 by 2, right? So the value of d will be 3.5 minus 3.5 by 2. So it will be 1.75 meter. So central length subtended equals to LC divided by r minus d into 180 by pi. So what will be this answer? The value will be 26 degree 307 minute 56.14 second will be the answer. Okay, you can solve it. So what is the value of yam? Yam equals to r minus d cos alpha by 2 plus s minus lc by 2 sine alpha by 2. On keeping all those values, we'll be obtaining the value as 30.49 meter. You can solve it. Please do solve it, because it's very important. So in the next video, we'll be explaining about the gradients, and it is very important topic of this chapter 3, the vertical gradient that is provided in the curve. And I'll be seeing you later in that video. Bye bye.